Hey everyone, welcome to the next tutorial. Now I've made a quick outline for the things that I want to go over today. So I'll just run through this really quick. I want to talk about a few of the internal Java API classes. These are going to be the string class, the math class, the NumberFormat class, as well as the DecimalFormat class, and some more work with the scanner class, which we've used a bunch now. And this is going to help to solidify the concepts of instantiation, constructors, and methods for us. And then when we talk about these formatting classes, I'm also going to show you guys the printf statements, which allow us to achieve pretty much the same thing that we can with these. And you'll see how this all works when we start doing examples. And then finally, I want to talk about the wrapper classes. And what these do are allow us to do something called autoboxing. So we know about the primitive data types, and these are type int, double, char, boolean, etc. Well, with these primitive data types, when we have a variable with each one of these, let's say we wanted to either set those values equal to null, or if we wanted to do some kind of an action with those, so run a method against them. Well, we can't do that with the primitive data types, but we can with their respective wrapper classes. So each one has its own mapping. So for type int, we have the integer class. For type double, we have the double class. Char has the character class, boolean has the boolean class, and then finally, I put this with a red line here, void, there is a void wrapper class, although we can't specifically instantiate an instance of it. Now all of these wrapper classes actually are children to the parent class known as the number class. And with autoboxing, and we'll see how this works, what we can do is, without really running any methods or anything, we can directly store a value of type int into an object of the integer class. Or the same thing with the types double, character, and boolean. So we'll do a little bit of work with each one of those. So just go ahead and open up Eclipse and we'll create a new project. Let's go ahead and just call this something like classwork. And now we'll right click and go to new, create a new file, and the first one we're going to work with is the string class. So go ahead and just name this something like string objects.java. Put a little comment at the top, something like use of string class and methods. I actually spelled that wrong, so let's go ahead and make our class declaration. So we want public class string objects, and then our main method. And we need to start with any string, so you can name this whatever you want, and then just store song lyrics or quote, whatever you want in there. Let's just put winter is coming. Hopefully not. And now, before we move forward, if you remember from our previous lesson, when we create objects, what we usually do is we start with the name of the class, and then we give our object instance a name, and then we use the equal sign and the new keyword, which causes it to undergo what we call instantiation. And this is setting aside some memory for our object. So we're referencing this object in memory, and now we invoke the special method inside this class known as the constructor, and the constructor always has the same name as the class to which it belongs. So in this case, the class and the constructor is string, and then parentheses. And in some situations, the default constructor will have no parameters, or in some situations it will require you to put in some kind of a parameter. So in this case, we could put in our same phrase, and essentially we've done the exact same thing in both of these lines. This is what you normally see when we create objects, but the string is a special case which allows us to kind of bypass using that new keyword, and we can directly store in using just quotes whatever our array of characters that we want to store into this string. So now the first thing I'll show you is the static methods available. So just using the class name string, if we hit period, we can see all of these static methods that are available to us. So something like format or value of, and it's only a limited number. So if we go back and use our actual instance of the string class, so we type phrase and then put a period, we have a whole lot more options for different methods available, as well as towards the bottom we have all of those static methods as well. So if you start at the top, and this is why Eclipse is good again, we can see on the right exactly what all of these methods that are available to us will do, as well as what parameters they require us to specify. So in this case, the parameter, it requires us to specify an index location, and then it'll give us the character that occurs at that index location. And this works similar to the way that arrays work, in that if we can just use our example, here our letter W occurs at position 0, and then the final letter, which is G, occurs at the length of this string -1. So let's actually backtrack a little bit, and we'll type an integer value L, and this stands for length in this case, is going to be equal to our phrase dot length, and if we invoke this length method, it returns the number of characters in our string. So now we can go ahead and just print this out and put string is L characters long. And let's just go ahead and run that, and we can see that our string is 16 characters long. And if we were to actually go ahead and count these, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, we can actually parse through, and this actually might be a good time to start talking about the printf statement. So you can see here that we had to put a string segment and then exit out and do concatenation with our variable, and then keep going. Printf actually allows us to do something where we can, I'm sorry, I forgot the System.out.printf. It's going to allow us to write our entire string. So string is, and now if we wanted to put in this value, what we can do is use the percent symbol, and I believe I have this open so that we could quickly jump to it. Here are all of the things that we can specify after our percent symbol that will allow us, to do what we're about to do. So let's go ahead and just use the letter D, and I'll show you how this works. %D space characters and now afterwards we have to tell it what we want to replace this %D with. D, as we can see back on that page, corresponds to a decimal integer value. So let's go ahead and put our L and then close this out. And what this is going to do is it's going to expect some kind of a decimal integer value to be placed in there, and then afterwards we have to give it either directly a value or a corresponding variable of that type, which we did there. So now if we go ahead and run this, we got the exact same sentence printed out twice. So this is just an alternate way of writing this without having to do concatenation. And in some situations, I'm also going to put in %n here. And all that's going to do is give us a new line. So if we wanted to then print something out below it, new line, this is on a new line. If we left this out, what it's going to do is put that on the exact same line, and alternately we can use this other \n switch, and that would put it on a new line. So there's a whole bunch of different options that are always going to be available, so you can do things in many different ways, but I just want to make mention of these so that you're aware of them. And later on in one of our next few classes, we'll go ahead and use the %f to format how we want our decimals to look. And you can see here, just a quick rundown, we'll be able to specify how many decimal places we want to display. So a few more things we can do. Let's go ahead and make another string, and I'll name it variable 1. We can take our initial phrase and do some other things with it. So we can take it and, for example, change it to all uppercase. And of course, if we printed that out, it would be now in all uppercase. Or we can convert it to, let's say we want to replace some letters. So we have this replace function, which is going to take an old character and replace it with a new character. Again, with characters, we want to put those in single quotes. So let's take all lowercase letter I and replace it with lowercase letter x. Go ahead and print that out. And you can see all of the letter i's have been replaced with the lowercase letter x. So we'll just do a couple of these. String variable 3 is going to be our phrase, and then let's go ahead and do the substring. And substring is going to allow us to specify a beginning index. Actually, let's go ahead and do the last half of it. So we can start that by doing phrase.length divided by 2. This is our var3, so I'll go ahead and print that out. And here we have the second half of our phrase. The other one we can do is specify from a position to another position. So we'll do var4 equals phrase.substring, and that's the second substring method. And here you can see that these methods both have the same names, but in different circumstances they'll do different things depending on which parameters we send it or how many parameters we send it. And this gets into a concept known as method overloading. So we can have multiple methods in our classes with the same name, but they all have to take different parameters in order for the compiler not to throw some kind of an error. So again, this one takes just one parameter, and this one takes 2. And the way this one will work, we want to give it a beginning index and then an end index. So let's start from 0, and let's go to our length, phrase.length divided by 2. So now we're going to go from the beginning to the middle of this phrase and store it into there. Whereas in this one we started from here and then it's just going to continue to the end. And again, I'll just point out that you can run multiple methods inside of themselves. So here we're running the length method inside of this substring method. So let's go ahead and print out our var4. And here we have the first portion of the sentence. This is the second portion above it. And now we can go ahead and do concatenation, which we know is the use of the plus, which we've done here. But there's also a specific method for that. So we can take our, we'll just do var4 dot concat, and then we'll add our var3 to it. And now we've put back together our entire original phrase. And again, here we're running a method to print out, and then we're taking this and running another method on a different variable specified as a parameter. So we're doing multiple different things all on one line. And here it's still easy to follow exactly what we're doing, so it's not getting too complicated, but it allows us to simplify our code a little bit rather than writing many different lines of code at once. And finally, let's just show that we can do the for loop, and this will reiterate the fact that the string behaves in some ways like an array. So we'll have an integer I equals 0. That's going to be our index value. And then as long as I is less than our initial phrase length, we'll add 1 each time through. And now let's just put on a different line each time whatever the phrase.character at the given index each time through the loop. What we're going to get is our initial phrase printed one letter at a time as it goes through this loop. So for I equals 0, we get the character at position 0, which is, again, W. And then we knew that the length was 16, so this is going to go until I is less than 16. So as long as I is 0 through 15, we'll print the character. And again, G occurs at position 15. Then this I becomes 16. 16 is not less than 16, so now we're done with this loop. And that pretty much covers everything with the strings. You can, of course, keep experimenting with it, and you can see all of the different methods that are available to you. So you can just mess around with all of these and see, different things that'll be useful for you later on. Now, another class that we should start to work with is the math class. So let's go ahead and create a new class file, and let's just name this math object. Objects, math class and methods, public class math objects, and then our main method. And now let's just make a quick program that will handle the use of the quadratic equation. And if you don't remember this, a quick refresher, usually quadratics will have the form ax squared plus bx plus a constant c. And usually you can think of this as like a parabola. So when we graph those, a lot of the times you were asked to find the roots of that. And what the roots are where it crosses the x-axis. So roots and for the typical parabola, of course, you only have just 2 roots, or points where it crosses that x-axis. And the way that we would find that, and sometimes there are simpler ways, but the fail-safe way is to use this long formula called the quadratic equation, formula. And that is the roots are equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So let me just put this in brackets to really show the association with all of this. So we want to turn all of this into a quick math little program here. So what we're going to do, first we need some values. So we need our integers a, b, and c. So we'll have a, b, and c. And we're also going to want to store each of the roots. So there's going to be, as we said, plus or minus. So there's going to be 2 roots. And we'll make those of type double, root 1 and root 2. And then just to make things a little easier for us, we're going to take this entire statement here and store it into a variable we'll call D, which actually kind of stands shorthand for discriminant. And I'll put a little note: if discriminant is negative, then not a number, NaN, which is not really an error, but this is what will be returned to us in this case because you can't take the square root of a negative number. So that should be enough information to get started. Now what we want to do is take some user input. So we'll ask the user for each of these values, their A, their B, and their C. So we'll start with, of course, we need a scanner object to take user input. So scanner class, we'll name it scan, equals new scanner object. And specifically, we want to specify system input as our parameter. And we need to import that. So I'm going to use the shortcut Control-Shift-O, and you can see it pops this import up at the top. The scanner class occurs inside the package java.util. And now we want to start with our System.out.print, not Percentn, just the regular print, and say enter a coefficient for x squared. And so now we're going to store that into our A. So A is now going to be equal to whatever we scan, and we're expecting this to be an integer value. So we'll use this next int method. And to make it a little easier, let's just go ahead and copy and then paste. And we want to change this to not x squared, but just our x in this case for our B. And just make sure you change the variable. So now B is going to be our next int. And then finally for this situation, enter a constant value. And this is going to be our C. So we can actually go ahead here and just print out the equation is, and rather than doing concatenation, let's just go ahead and use that printf that we had just learned previously. So we know it's going to be all integers. Let's go ahead and use the %d, and this is going to be x squared plus %d x plus %d alone, and then let's just put a %n for a new line right after. And now we need to add each one of these variables that we're going to replace these with. So the first one we want is A, B, and then C. So at this point we can go ahead and run this, and it's going to ask us our question. So let's just go ahead and put 2, 4, and 5. And it prints out 2x squared plus 4x plus 5 using our printf statement. So of course we want to do a little bit more with this, and so we'll go ahead and just, now we want to set our discriminant value equal to, and in this case we had b squared minus 4 times a times c. So the way that we can do b squared, of course we could just do this, but what happens if you wanted to do b to the 10th? Well, you would end up sitting there going times 3, that's 4, that's 5, and you'd have to do this 10 different times. It would work, but it's not very efficient, especially when you're coding it. So the simpler solution is to use the built-in math class, and then rather than actually making an instance of the math class, we can use it right in line using the static methods available. So let's go ahead and just do math dot. You can see all of these static methods, And we can go down here to the power one, and it's going to take, the first argument is going to be the base, and the second argument will be whatever the exponent is. So our base is going to be our b, and our exponent is going to be squared, so 2. And now we want to take that and subtract from it 4 times a times c. So 4 times a times c. And again, I've just been a little liberal here with my parentheses so that I can make sure that everything is associated the way I want. So I want to do all of this and do this separately, and then take the value of this minus that and store all of this into D. And just put a note, well, I put that up here. If D is negative, then we're going to have somewhat of an issue. So the way we can actually alert the user to that, so we don't confuse them, is say if D is less than 0, so if D is negative, go ahead and print this statement. Discriminant value is negative, therefore not a number. And then we can actually go ahead and just put the D so that they know exactly what it is as well. Now again, this is only going to execute when this evaluates to true. So as long as D is positive, this will never actually be printed to the user. And now finally we need to store the roots. So we'll do root 1 is going to be equal to, and the way we can get negative b is to do negative 1 times b. And the first one we'll do is plus, so negative b plus the square root of our d. And the way we can do square root is, again, use the math class, go all the way, we go all the way down to s, I didn't go far enough. Square root, it's pretty self-explanatory, so now we're going to put our d in there. And again, I'm just going to overly associate all of this. So we want all of that divided by 2 times our a. And now we should be good. So let's just go ahead and copy all of this so that we don't have to write it all out again, and paste it, and just change your root here to root 2, and then change this to the minus. And so finally I can print out, and let's just go ahead and again use the printf. So I can say the roots are, and then I'll say, let's put it on a different line here. So %n, that's going to give us a new line. And now let's go ahead and do /t to tab it over a little bit for formatting. And let's just say root 1 equals %d. And now again, %n for a new line, /t. And we'll say root 2 equals %d, %n. Sorry about that. So we're not done. Now we need to replace our 2%d values with what we want. So we'll do root 1, root 2. And this can actually start to get pretty confusing, and it's probably not the best practice, but I just want to show you some examples of how we can use the printf statement. So that's why I'm doing this here. So now we should just go ahead and run this, and now I need to pick some values so that we don't get not a number. So let me just, hopefully I can, let's do 2, 6, and -3. Where did I mess that up? Line 37. It doesn't like. Let me just space these apart a little bit. Aha, so we actually should be using the %f here. That was my mistake. So let's just change those to %f, and then hopefully we don't, let's do 2, 6, -3, and there we didn't get the issue. The problem was we were not using %f to correspond with our double or floating point values. So we can actually go ahead and collapse these down again. And there you have it. It works properly. And let's just try and trigger that little problem I was talking about, 3, 6, 9. Okay, so there it's printing out, in this case, the discriminant value is negative, therefore not a number. And it gives us, at the end, that value D as -72. So again, you can see that we got this NaN in response for our roots. Let me just double check back. So we've gone over the string class, the math class, and let's just do a little bit with the formatting class, and we've seen some formatting using this. And then we'll just talk about the wrapper classes as well. So we'll do one more class. Let's go ahead and create a new one. And in this case, we'll do some work with circles. Just do our class declaration here, circles, and our main method. So the first thing that we know about circles, that we need to use pi, which is generally 3.14, although it's a much larger number. In fact, it repeats forever as far as we know. And then we also have the radius, we have diameter, and we have circumference. And knowing those, we can go ahead and get area. So the formula for the circumference is 2 times pi times our radius, or just pi times the diameter. So diameter, of course, is just twice our radius, or radius is half of our diameter. So knowing either one of those, we can get to the other one. And then importantly is the area, which we know is pi times r squared. So what we want to do is have a user give us, let's say, the radius of it, and then we're going to calculate some of this information and print it back out. So rather than using the double class, and actually, no, I'm going to go ahead and do our normal primitive data type double, call that the radius. And now I'll just show you that with the primitives, we cannot actually set this equal to null. And if we try to, we get this error here, which says cannot convert from null to double. But we can add a cast so that it is translated into an object and then stored back into this primitive data type. So actually what we're doing here is we're using Autoboxing to translate from an object wrapper class double into a primitive data type double. Now, this is a little bit confusing, but I'll show you how that works in a minute. We're also going to want to store the area, so I'll do this one using the object, the wrapper object double. And the way that we would usually instantiate this, if we were to specify this directly, is new double. And let's leave that. It's going to give us an error because it expects some kind of a value here. So what we're going to do is just specify 65.35, and that error should go away. So the default constructor for double can't be empty. It requires some kind of a parameter as input. So we'll just take this away for now. We're only going to name our object. We're not going to actually create it yet. And let's also go ahead and we'll create another one called circumference. So now we need a scanner object. Scan equals new scanner for user input. So System.in. Control-Shift-O imports. Out.print. And say enter in a radius. And so our radius is now going to be set to whatever the user inputs next. Double. And again, our radius is a primitive data type. So now inside of our area, which is a double object, we want to store whatever the calculation is for pi r squared. Well, we've seen already how to do the power rule in the previous example. So now we just need to set a value for pi. And the way we can do that, again, is to use the math class. And it has its own constant for pi, as well as one for e. So we'll use this. It's capital Pi. So we want to do that times our math.power using our radius as the base, and then we want to square it, so 2 as our exponent. And so here we've taken this constant value, which is a primitive double, and then we've also taken our primitive radius value, and we've multiplied these two primitives together, and we've stored it into a double object. And I'll make it a little more clear exactly what's going on, but again, this isn't a case of where we're doing autoboxing. So let's go ahead and just print out the area of that circle is let's say our radius is 5. We get the area at 78 points and this long decimal value. Now if we wanted to explicitly see what the value for pi is that they're using, let's go ahead and create a double primitive type called pi, and I'll spell it wrong on purpose here, but let's do math.pi, and let's print that out. 5. Okay, so here's the value of pi that they are using inside the Java language. So what we can do, and here you can see we're using our value pi is strictly a primitive data type. So again, if we try to run any methods with that, nothing shows up because it's not actually an object. But if we wanted an object, we could do double, let's name this one pi, lowercase, is equal to whatever our pi primitive data type is. And here we've directly stored into an object from a primitive data type. So again, we've taken object and we're storing into it from primitive. Now alternately, we can take this object and we can store into it, store it into another, let's just name this one X for this. So here we've taken a primitive and stored an object directly into it. Not really an object into it, but we've converted the value on the fly and stored it right into this variable. So even though these are, one's an object and one's a primitive, we can immediately switch, and this again is this concept of autoboxing that we've been using. In this case, since we're taking the object and storing it into the primitive, it's referred to as unboxing. So we have autoboxing, or just boxing, and then here we would have unboxing. And this is pretty convenient and helpful for us. So again, if we wanted to take our PIE, which is primitive, we have no methods that we can run with it, but if we took the pi, which is this one, we have a whole bunch of different methods that we can run using this. And here are some of the more useful ones. So let's say we wanted to take a string, and I'll name this just number equals, and then our string is going to be, let's say 42. Well, we can't automatically do autoboxing with that, so if we wanted an integer y equals our number, this isn't going to work because it can't convert from string to int directly. But what we can do is use the integer wrapper class and use one of its associated methods. In this case, we want to do toString, and it's going to return a, I'm sorry, we don't want the string, we already have a string. We want the parse. So if I find that, or get integer rather. Oh, here it is, parse int. So we can use this parse int to take a string and get the integer value inside of it out. So again, we're taking the integer wrapper class, using its method parse int, and specifying as a parameter a string value. It's going to store whatever the integer value of that string is inside of y, and now we can go ahead and print out y is, now let's run this, and we can see y is 42. So by using these wrapper classes and some of the methods associated with it, we can convert from various different types, especially from the primitive data types, into some of the object classes and switch between them. Now, of course, if we weren't certain that number was going to be containing what we wanted, so what happens if we had just some word in here? Now, if we do this, what are we going to get as a result? Here we get an error thrown, and this, if we weren't careful, we would have this error thrown, or we can choose to handle when this gets thrown, and that's for later on when we start doing exception handling. And now finally, let's go ahead and start doing a little bit with the different number formatting. So again, we said that pi was displaying all of this for us. And let's say we only wanted maybe 4 decimal places of significance for pi. So what we can do with that is use the DecimalFormat class, and I'll name this df. And in here we can specify certain patterns, and we'll do that inside of quotation marks. Let's say we wanted 1, 2, 3, 4 decimal places. Now we need to import this. So we'll do df.format, some kind of a double, and in this case we'll specify our pi. And let's go ahead and just print this all in one line. So go ahead and put print line and put that right in between the parentheses for your print statement. Now if we run this, here you can see you got 1, 2, 3, 4 decimal places. Now alternately we could specify a few different patterns. So if we put, let's say, 3 zeros there, and let's say we wanted some zeros afterwards, is this going to give me a problem each time? It is. I haven't worked with this one in a little while, but we can get the zeros so essentially you get the same thing here, but what this would do otherwise is allow you to put the zeros if you didn't have enough numbers to fill out that. So here, of course, it ends at the 3, as we can see there, and then it's going to put the trailing zeros afterwards for us. So again, if you wanted a, let's say, 5 levels of zeros before the decimal, we can add that in. And this way you can guarantee that no matter whether we have, let's just say 1.0 as our number we're displaying, you'll always have the same number of characters in your representation. And now one more that we can use, and I'll do all of this right inside of a print line statement, is the currency formatter. So with that we can do NumberFormat dot, and then we have this get currency instance, and we also have the get currency instance with a locale, and I'll show you that one in a second. Let's say we wanted to convert our pi into some kind of a price looking, so we can do format, and now let's go ahead and use our pi. And let's just run that. Here it's converted this so that it only has 2 decimal places afterwards. And what this is going to do is actually round up or down depending on the next value. So here we had a 1, obviously it just kept this as a 4. If the number right after it had been a 9, this would have rounded up to 3.15, and it automatically adds that $ for you. So let's just copy and paste this. That value for the get currency instance we can do locale dot, and these are for all different countries, because some countries, rather than using the decimal point for what it is, actually interchange it with a comma. And we'll just select France, for example. So let's do the same thing, format, and we'll do our pi again. Go ahead and run this. So here, it rather than using that decimal point, it uses the comma, and it's going to go ahead and use the euro instead of the $sign. So for anybody outside the country, or if you're working with international currencies, you can use this locale to specify exactly which country you're targeting. And then finally, I'll just point out, since we used a scanner object, it's giving this little resource leak warning here. And anytime we work with data streams, and this, since we're taking a data stream from the keyboard, also when we work with sockets and things later on with actual networking, anytime you're handling a data stream, you want to make sure to close that. So we'll do scan, and the first one that pops up is this close right here. So it's usually won't be a big problem, especially in the beginning, but it can cause problems later on. So it's good practice to get in the habit of handling that early. Now let me just go back, and I think I covered all of the topics. We did the printf, scanner, number format. Yeah, so that about covers it for this tutorial. And in the next tutorial, we're actually going to start to break free from just staying within one file for our programs, and we'll start creating other files that we can start interacting with, and also begin creating our own class files that we can start bringing in. So rather than relying on, say, the scanner class, which is part of the API already, we're going to create our own and start to bring those into our programs. So again, thanks for watching, and check out the next tutorial.